This will be a video about computing the derivatives. One simple way is, again, you type these expressions in Mathematica and name it as a Formula 1, something like this. And then you're supposed to have these x's in a blue color so that it is a new variable, it's not assigned anything. And this is the command, the capital D, an argument in the formula differentiating with respect to x. Then you're supposed to get this type of answer. So you differentiated this expression with respect to x one time. If this is not quite the form you wanted, and then you can use like a simplify command, and you can redefine formula 2 and after you simplify like this, and then it gives this type of result. So often we want to evaluate that derivative at somewhere. So derivative values at some value x, like x equals 2 or something, then you have to plug in x equals 2. That will be a substitution rule. So let's think about how we substitute x equals something. So here's how you do it if you remember. If this doesn't make sense, go back to the substitution rule video and review those. Here's a derivative formula. We actually call this one formula 2. So in the second line, I'm actually using the formula 2. So I'm doing the same thing and 2 times just to show you different ways of doing it. If you have already defined a formula 2, and here's the syntax for the substitution rule. If it is just a one substitution, you don't need the parentheses, but we had it before, parentheses around it. But if it is just a one substitution like this, and you can do it in just this way without parentheses. So x is going to be replaced with the square root. 2 point means we want numerical value. So if you do these two things, then you will get supposed to get the same answer. Right, this is the answer you're supposed to get. So let's take a look at the example that you have to take the derivative multiple times. If you want to differentiate the same function 3 times, and now we're going to do that, for example. So here's how you do it. So I take that formula 1 again. This time is differentiating, but not just x. If you put this 3 and the parentheses around, it's going to be differentiating formula 1 3 times. That's the same as I'm doing this over and over. So that I call the formula 3, and I simplified it. And because if there's no semicolon, it's going to show what it did for the first line. Then also show the formula 3 with this substitution. That means 1 times pi, so it's going to turn pi to a numerical value. Then it shows this third derivative and simplified form of the third derivative of the formula that I showed earlier, and then in the second line it plug in 3.14, that numerical approximation, into this formula and get this value. Here's another example, and this example actually has a and b and c. These are unknown constants. It's not variable, but undetermined constants in it. Again, the Mathematica does this type of algebraic computation, so it will calculate the derivative this time 3 times again. So if you calculate this and simplify, and then it's going to do this symbolic calculation with the a and b and c in it. Then if you kind of do the substitution not only for the x values, or actually realize that I threw in this y as a, so I'm looking at this as 2 variable polynomials and differentiating only with respect to x, and so that's the x and y is the main variable. We have values, but let's say the situation is you know what a and b and c you want to plug in, so you can make this substitution all at the same time at the end, and it's going to turn this one into a numerical value. Of course, if you just plug in x and y in there, it's going to show you the result with a and b and c in it. So this is how you find the derivatives and the values of the derivative in Mathematica.